This is a lesson on direct variation. So a function that's in the form of y equals k times x is said to be a direct variation problem, and we read it in the form y varies directly as x. K is called the constant of variation, and we can find k by just dividing y by x. So y divided by x is what will equal the constant of variation, and k cannot equal 0, otherwise we just have y equals 0 and then it's not direct variation. To determine if there exists direct variation is to find some k, some constant of variation, so that equation, the direct variation equation, holds true. So here's an example. Determine if y varies directly as x, and if it does, then find the constant of variation and write the equation of variation. I have two examples here. The first one is using a table of values. So we have this table, this t-table of values, and we can have our x's, our inputs, and our outputs. And we are trying to determine whether or not is there a k. If each one of these has the exact same k, then it definitely is true that y varies directly as x. So we look at y divided by x for each one of these ordered pairs. And we get 3/2 for the first one, and we get 3/2 for the second one, and we get, sure enough, 3/2 for the third one and the last one. All of them have the exact same y divided by x, which means there is a constant, and so therefore y does vary directly as x. So now we have to go back up here and say, all right, find that constant of variation. Well, this is that constant. It is constantly the same thing. So k equals 3/2. And then write the equation of variation, which is to write it in the form of y equals kx, but use the k. So we have y equals 3/2 times x. And that's the end of this problem. For the next problem, we're going to look at it as ordered pairs. So we have this set of data, these 4 points, and we do the exact same process. We try to determine, is there a k, is there some constant? So you're constantly going to look at y divided by x. So we're going to have 4 divided by 2, which is 2. The second ordered pair is going to be 9 divided by 3, which is 3. And the next one's 16 divided by 4, and 25 divided by 5, and you'll notice that none of those are the same. It's not a constant. It changes. So therefore, no, this is not a direct variation problem. For the second types of problems, you're going to be given some data about this direct variation, just one set of data that says, I've got an x and a y. And you need to find, with that set of data, that one set of data, find the constant of variation. Then write the equation of variation to determine the missing value. So here's an example. We're given one set of data. We're given that when y equals 5, or that if y equals 5, then x equals 2, or however you want to say it. We've got that one set of data, x and y. What we don't know is this y, so we need to find the y. That is what is the missing value. So step number 1 is to find that constant, and we know that that's going to be y over x, and so we use the first set of data, this 5 and 2, and we find that we get 5/2. Well, that is your k. Using the k, we write the direct variation y equals k times x, but we have this x equals 7, so we're going to plug that in. So we plugged it into the direct variation equation and simplify, and we get that y equals 3/2, and that's what we were out to find. We were out to find y, and we found it. Second problem. We've got this, and we're told that it's a direct variation, so I know that's true, and I have one set of data, 6 and -3. So I try to find my constant, which is going to be the 6 divided by -3, which is -2. Now we write it in the direct variation equation, knowing that y equals -4 was given, and what we're trying to find is x. So we're going to plug in that y equals -4, and there we have it. So you have to be careful that this time we were plugging into y, and we need to solve for x. Well, to solve for x, we're going to divide both sides by -2, and we get -4 divided by -2, which says that x equals 2, and that was the missing information, was our x. So we have found it. That's the end of your lesson on direct variation.